This is Maths Linear Algebra Tutorial 7, question number 6. These questions ask us to prove Theorem 14 of Lay's book. In this theorem, we are given a matrix A that is rectangular, m by n, and it states that the following three statements are logically equivalent. That means that given any one of the statement, the rest will be implied. The most easily understood statement would be statement number B, where given the matrix A and we are told that the columns are linearly independent, then the other two information is logically equivalent, means that it will be also true. That is, given A has independent column, then A transpose A inverse exists. That is the statement number C. Additionally, statement number A says that we can use the normal equation to solve for the least square solution x hat. Because A transpose A inverse exists, A transpose B is given to us as A, B exists, then x hat can be solved. Not only can it be solved, the interesting thing about x hat is that in the statement it says that x hat is a unique solution. There is no other x hat that will exist. The proof is outlined in exercises 19 to 21, which is our three parts of the question number 6. We'll now begin with question 19. Question 19, again, we state that m by n is a rectangular matrix, and we want to prove the following. We want to show that the null space of A is the same as null space of A transpose A. The argument has two steps. The first step is to prove 19a. We are given Ax equals to 0. We have to prove that A transpose Ax is also 0. What this means is we are saying when Ax equals to 0 means x belongs to the null space of A, it is also the null space of A transpose A. In the second step, we go the other way around. We are first told that A transpose Ax equals to 0. X is a null space of A transpose A. Then X is also the null space of A. That is, we first start with the null space of A transpose A, and we want to show that it is also a subset of null space of A. When these two has been shown, therefore, we are showing that the null space of A is equals to the null space of A transpose A. Let us now work first 19a. In 19a, we begin like this. We first suppose that Ax is equals to 0, meaning that x belongs to the null space of A. We have not decided what x is. We just say that x is a null space of A. X can be the trivial solution or any other x that satisfies Ax equals to 0. We now wish to prove that ATAX will also be equals to 0. And this is quite easily done. We use what is given, Ax equals to 0. We pre-multiply both sides by A transpose. And since on the right hand side is multiplying by 0, we still get the 0 solution. What it shows is that A transpose A, x is equals to 0. We now look into this matrix and we realize that because x for this matrix gives 0, therefore x also belongs to the null space of A transpose A. We have proved the first 19a part. In the 19b part, we are given A transpose AX equals to 0. What this means is that X belongs to the null space of A transpose A. We wish to see that AX will also be equals to 0. What we do is that we take the first equation, A transpose AX is equals to 0. We pre-multiply by X transpose. We recognize this as AX transpose since this is X transpose A transpose. We then write the second part, which is this. On the right hand side, X transpose multiplied by 0 remains the 0 because it is multiplying by the 0 vector. Now we turn our attention to the left hand side. This is the square of a vector. It is nothing but the length of AX square. What we now recognize is that for the right hand side to be equals to 0, since A is not equals to 0, therefore X must be the 0 vector. Or X, I should say, belongs to the null space of A. Therefore, we have shown that when X is the null space of A transpose A, then X also belongs to the null space of A. Since we have proved it both ways, therefore the null space of A is the same as the null space of A transpose A. This is the result that we want to achieve for question 19A and B. Thank you.